In this video, we are going to go over how to create a Campbell diagram like the one here shown on the screen. We are going to use the results from a rotordynamics analysis that was performed with MSC Nastran. Now, for today's example, we are going to be using an example found in the MSC Nastran Rotordynamics User's Guide. If you look in Chapter 6, they have an example where they go step by step on how to create the rotordynamics model. Now, what we're interested is the very last step, where we want to create the Campbell diagram like you see here on the screen. Today we're going to be using the following bulk data file, RUG62. This is actually the bulk data file that I have here on my desktop. But before I get to the bulk data file, let me make a quick comment about the tool we are going to be using today. I know creating graphs takes a long time, but today we're going to be using the HDF5 Explorer to quickly build our graphs today, which is the Campbell diagram. The HDF5 Explorer is free as long as you are an MSC Nastran user. If you're a student, researcher, professional engineer, or professor, this tool is free for you to use. Also, the HDF5 Explorer is only compatible with MSC Nastran. I know some of you are using other types of Nastran. Know that this tool is only compatible with MSC Nastran. And why is it only compatible with MSC Nastran? MSC Nastran is the only tool that outputs the H5 file format. So here, let's go ahead and run Nastran. And if you look here, my results are contained in the standard OP2 file, but they're also included in the H5 file. We are going to be using the results found in the H5 file to create our Campbell diagram. This is why the HDF5 Explorer is only compatible with MSC Nastran. Now, if you want to start using the HDF5 Explorer today, if you go to theengineeringlab.com, in the top right hand corner, there's a button that says free download. Click that button, fill out the form, and we'll send you a link to download this software so you can go ahead and download and install the software on your own desktop. Okay then, so let's go ahead and get started. If we look at the bulk data file, this is what we need to output data so we can create our Campbell diagram. If you look at the case control section, in subcase 1, there is this command, Campbell 100. This 100 is a pointer to this other Campbell bulk data entry that you see on line 25. So what does this entry mean? This entry is saying the following. Output data for a Campbell entry, or rather, output data so I can create a Campbell diagram for speeds 11, where 11 is a pointer to this DD val. And then if you look at this DD val entry, you have the following speeds. Speeds 10,000 through 0 in increments of -1,000. So again, this Campbell entry is going to output data for speeds 10,000 through 0 in increments of -1,000. Here on the far right of the Campbell entry is RPM. So even though the speeds are supplied in revolutions per second, we want the data to be output in revolutions per minute. So now let's go ahead and run Nastran like we did a few moments ago. We've already done this, so we have the H5 file. Now what I can do is go to the home page of the web app. Here, click on HDF5 Explorer. Upload that bulk data, or not the bulk data file, but upload the H5 file that contains the results of that rotordynamics analysis. Here, let's give it a moment to automatically open. When it's done, let's go ahead and click on Acquire Dataset here on the top navigation bar. If you want to create the Campbell diagram, you need to select the Summary Eigenvalue Complex Dataset. Here in Specify Entities, I can specify which modes I want to create a Campbell diagram for. Do I want this for modes 1, 2, and 3, or do I want additional modes? If you want to select all the modes, you can type all then click acquire data set. Then here, if you look through the table, I have data for all the modes. Here on the top right, I can click on create plot. On the top navigation bar, this link, last plot added, starts to blink. Click that link and it takes you to that graph we've created. It takes you to the plot we've created. So this is 95% of the Campbell diagram that we wanted to create. We have frequency here on the vertical and then speed in the horizontal. If we wanted to, we can go ahead and select which modes we want to plot data for. We can move the data left and right. We can move it up and down. If we want to, we can zoom in and look at the data a little bit more closely. If we wanted to, here in the toolbar, click on home, and then we've reset the graph. You can zoom out if you wanted to or zoom in. But there's one thing missing in this diagram. I don't have the order lines. The order lines are not output to the result file. We have to add these manually. So how do we do this? Here at the bottom left, click on View Filters and Plotted Values. The data for all of these lines is in this table. Here on the top right, click on Download CSV. I now have CSV file in my downloads directory that I open in Excel. I can select these cells and let's go ahead and create a quick plot. We'll go ahead and switch the axes. And this is the same Campbell diagram that we had in the HDF5 Explorer. Let's go ahead and do the following. Let's go ahead and let's go ahead and add some axes labels. So frequency, this is going to be in hertz. And then for speed, this is going to be in RPM. Now, quick comment about the values along the horizontal axes. Let's go ahead and find out what the last value is. Here, the last value is this 166.666 RPM. Let's go ahead and multiply that by 60. And you see that this is 10,000. Remember that when we configure the Campbell entry, we wanted data for speeds between 10,000 and 0 revolutions per second. Here, since we use the RPM option in field 1, 2, 3, 4, 5, here's field 5, it's set to RPM. The data that we have is not in revolutions per second, it's in revolutions per minute. So that's why here I put RPM so we know what the units are. Okay then, so now that we have this data, let's go ahead and create the data for the order lines. So here in row 18, 19, and 20, I have orders 1, 2, and 10. So let's go ahead and generate this data manually. So we'll take the speed, multiply that by the order number, and then we want hertz at the end, so we'll divide that by 60. Let's go ahead and make sure we're locking in this number. So these dollar symbols, when you spread this cell, it's going to use the same value 1 for the order. That's why I use these dollar symbols. And let's go ahead and repeat this for the other ones. So here we'll go ahead and move the order to order 2. Okay, that's the same speed. Let's go ahead and make sure we've done this for this other one. Here we want to use order 10. Let's go ahead and drag this here, and we'll do the same for this other row. And then for the data, for the graph, we'll go ahead and update it. Let's go ahead and make sure we've done this correctly. Okay. Here in the graph, if I wanted to, I can hide everything but the order lines. Let's go ahead and display the order lines. So this is what the order lines look like. Now let's go ahead and turn on all the other modes. So this is the final Campbell diagram. And let's quickly recap this exercise. So number 1, we use the Campbell command and the Campbell entry to output data so we can create the Campbell diagram. We output data for speeds 0 through 10,000. Instead of using revolutions per second, we output the data in revolutions per minute. We then ran Nastran to perform the rotordynamics analysis. We got this H5 file, and then at the end, I uploaded the H5 file to the HDF Explorer, where we quickly built the Campbell diagram. But since the order lines were missing, we had to output that data to CSV, and then at the end, we use Excel to add the order lines and create our final Campbell diagram. Now, as a last reminder, this tool, the HDF Explorer, is free as long as you use MSC Nastran today. It's only compatible with MSC Nastran, and if you want to start using this tool today, you can go to theengineeringlab.com, click on the blue link, fill out the form, and then we'll go ahead and send you a link to download the software and install and use on your own workstation. So with that, we'll stop here, and as always, thank you so much for watching.